Hello. Can you all hear me well with this microphone? No? Peter? Microphone?
Speak up.
Does it
Speak
work?
up.
Speak up, speak up.
Yeah.
I have to shout in here. Okay, I'll try. Please raise your hand if you can't understand me. Anybody? No? Okay. Jochen. Uh, so this talk is about a message bus. And I'm using, that's not me, my system is running. And I'm using RabbitMQ as an example. I hope all of you have been in Kerstin's talk, the first talk in this room here today, where she was talking about background processing and asynchronous processing, because that you already raised an understanding why you want to use a message bus, why you want to decouple your systems. So that was a good introduction, I'd say. So that's one of the main goals of it, is to decouple your services. You often start with a monolith, and then you want to extract parts out of it, and then you have services. And you might call them microservices. Most probably they're not microservices because they're still really entangled with the main system, and you have all these synchronous calls, and you have like one application, I don't know, a user fills out a registration form, and then you have your registration application that communicates with the main application to get information about the user, and it also connects to the mail application to send the user welcome mail, and so on. So you have all the control in one application. It's not decoupled. If you would send messages, you would just like say, okay, I've got a new user registration and I have an event. New user registered, that's the database ID. And your email system would listen to this event, would listen, oh, a new user registration, I'll have the ID of the user, can get the information of it, I know what I have to do as an email system, and then I send out an email. And you can even easily change the system, so you can add a third system. So let's say you also have to put this data now to Salesforce. You just add a Salesforce listener, which listens to the same event without you changing any code of the other side, and then adds this user information to Salesforce. So that's a big benefit. You can also use message buses to handle high volumes of messages. Let's say this user registration happens after you have a TV commercial. When you worked for a gaming company and you had like this TV commercial in a good spot, maybe you have like 50,000 new registrations in between a few minutes. The system has to handle this load somehow. When the user just fills in a form, and you save that to a database and then tell the user, great, you will receive a welcome email, that's fine. If you can decouple it, if your queue can queue all those messages where your other systems need a bit more time to process it, to send out the emails, to do whatever your system has to do, your system will be resilient, it won't fail, and you won't lose any of those really expensive registrations. You can also use it to broadcast messages, one event and just shout it out in the wild, and you're adding listeners time after time. I don't know, like a news feed maybe, which is only used right now for like 3 news sites here in Germany, but then you get more successful and other people also want to have the news. And you don't have to do anything, you just shout out events and you tell them at a client, at a consumer, listen to those messages. You can even use the same mechanism to replicate your data to another region in the world. Like you have your RabbitMQ broker instance here in Germany, and then you have another one in Asia, and you can handle the same there and for faster access on both sides of the. So I don't have time to go through all of that. I used this presentation before, and yeah, too much content on the slides. I'm sorry for that. On the left side, you see the publishers. On the right side, you see the consumers. In the center, we have basically RabbitMQ, the broker itself. It has exchanges and queues. And if you pay attention, you see that the publishers publish to exchanges. They don't publish to queues. It always goes to an exchange, and the exchange will route the messages to a queue. And I will later explain how that happens. And then the queues and the consumers are connected, and in our case, the queues will push messages to the consumers. And this slide just reminds me to explain ACK to you. ACK is short for acknowledgement. So because for right now, we're just pushing it all the way down the messages, but at some point we might want to have some feedback. Was this message received? Was this processed? Was there any issue? And for that, we're talking about acknowledgement, that you can have in the step to acknowledge that you received a message, and you can also have a negative acknowledgement, which basically means to reject a message. And I'll also give some examples how to handle that. Starting with the left side, publishing messages. So it's all, oops, that was a bit fast. It's all about trade-offs between speed and security. So AMQP and RabbitMQ in particular gives you lots of different options how to handle sending messages, consuming messages, what to do in between. And it's all about trade-offs. Do you want to be really secure that your message was received and handled, or do you don't care so much because, I don't know, maybe you have locks or whatever, you just want to push them as fast through the system as possible, don't want to have any delays, then you can go fast. So fast is no guarantees. You just send it from A to B, and you hope the consumer handles it. And if it drops a couple of messages, you don't mind so much. It's not so important for you. It's more important that the system doesn't get slow. There's an issue, though. You might overload the consumers, dropping a lot of messages in. We have a thing in RabbitMQ called publisher confirmations. So the publisher confirmation happens on the left side of this diagram. So when the broker was able to route a message from an exchange to a queue, and the message is happily sitting in some queue, then there's a confirmation sent to the publisher saying, hey, it worked, fine. It wasn't consumed yet, but the publisher knows my message will get handled. You can persist your messages, so you can make sure that usually all messages are always in RAM with RabbitMQ, so you need a lot of memory. If your system is fast enough, the memory load doesn't have to be so high because your queues empty themselves really fast. So that's fine. You can also persist them to disk if you're afraid that your RabbitMQ instance goes down at some point. It shouldn't, but you know, it can happen. RabbitMQ doesn't use Redis or so on. It has a built-in database that is optimized for writing, while most other databases are optimized for reading speed. And that is because usually it only writes the message to the database, never reads it, and deletes it at the end. It only reads messages if something happens, and it has to reload them to memory. You can create a cluster. You have like lots of different nodes, usually work with 2 or 3 nodes, and it's often used not for performance, but for more security, for redundancy. So you have like one master which replicates the messages to other nodes, and if the master goes down, you still have the replica and would take over and be the new master. It all comes itself. You don't have to do a lot of configuration to make this happen. And those queues we call high availability queues. So that was, in a really fast way, the left side. Let's go to the right side, consuming messages. Again, we have the same trade-offs, speed and security. So when consumers are listening to messages, and as I mentioned before, if it's really fast, we can overload them. So that's maybe something we want to prevent. So the fastest would be no guarantees. There's no accent, like nothing, no one acknowledges anything. Just give me all the messages you have. I might handle them or not. I can add a quality of service level. So that means I set a prefetch count, let's say, of 10 messages, 50, 100, whatever you want to put there. And after those number of messages, the consumer would send acknowledgement that it received those messages. And both sides are counting messages, like the queue side, the broker, and the consumer counting messages, and it just sends one ID. And then the broker knows if all were received or not. If not all have been received, it would send all of them again, so you don't lose messages. And it is quite fast without a lot of overhead. It can be even like more granular. You can send an acknowledgement after each message. So there's an automatic acknowledgement that would be sent when the message was received by the consumer. So your consumer receives a message, sends an acknowledgement, I got it. The issue with that is your consumer might crash. It might not handle this message, and you would lose it, actually. So you usually want to send a manual acknowledgement, and you do it after processing the message. So it takes a bit more time before you actually send the acknowledgement. So the whole process is a bit slower, but it's like really safe, a safe way of doing things. It all depends on how important information is that you're transferring at this moment. When I'm talking about an acknowledgement, as I mentioned before, it could also be a non-acknowledgement, a rejection. So the consumer tried to handle the message, but it didn't work. the data wasn't formatted well enough, or the external system it has to talk to was like not available, something like that. What happens when I reject a message? Theoretically, we could think the consumer sends a message all the way back to the publisher. Kind of a bad idea. The publisher gets a message that he's sent like, I don't know, minutes ago, maybe just a fraction of seconds ago, an hour ago, who knows. Just too much logic in the publisher. The consumer could handle it itself, but then it would need to know, okay, how do I handle messages that break? So it's also something we don't want to do. Usually we just reject messages and explain later another system of how to handle them, those rejected messages. Come on. Oh, sorry for that. There were some issues with that. Yeah, I hope you're still with me. Okay. Sorry. What is the computer? No, it's Bluetooth. Examples. I don't have time for examples, sorry. So we talked about the left and the right side, the publishers and the consumers. And now we're coming to the center. The broker, and exchange routing. So to connect the publishers and consumers, we have at least one exchange. And to this exchange, was it okay or not? To the exchange, we have to bind queues. So in each exchange, we will bind at least one queue in a usual case, or many of them. And we're binding queues in different ways, which I come to in a sec. So the broker routes messages from exchanges to queues. So we have different types of exchanges here for different use cases. In a direct exchange, the routing key would be exactly the same as a binding key. It matches, it's string matching. If string equals that string, done. Then you receive this message. Completely different type of exchange, the fan-out exchange. Every route that binds to a fan-out exchange will receive all messages that are received by the fan-out exchange. So it's like for broadcasting. And we have the maybe most interesting one, the topic exchange, where the routing keys are dot separated. And the queues define a binding key that actually does pattern matching. So with the asterisk, you can match a word, and with this hash symbol, you can match a word and dots. So basically the whole string. That actually allows you to emulate a direct exchange, use the exact same string on both sides, or to emulate a fan-out exchange while just using the hash symbol to just receive all messages of this topic exchange. And there are more types of exchanges. So the headers exchange, the headers are like parts of the message properties, and it's basically a hash with key values, which you can use for routing. RabbitMQ allows you to add plugins to have more different weird kinds of exchanges you might want to need, or maybe better not. You can also use exchanges to handle failure. Sorry, I'm using that thing here. So we have alternate exchanges. So whenever routing doesn't work, so you send, the publisher sends a message to the exchange, and it cannot be routed, because there's no queue defined with this key. Then you can use an alternate exchange that takes all these unroutable messages. So that would handle the left side. The message is received by the exchange, doesn't really work, it sends it to a different exchange, an alternate exchange. And there you can like put some monitoring on what happens if I have a lot of messages in the alternate exchange. So you want to, I don't know, somehow handle them. And you also have a dead letter exchange, which is for the right side, for the consumers. So the consumer receives the message, can't handle it, rejects this message. And I mentioned before, what do we do with rejected messages? So a good way of dealing with them is a dead letter exchange. In the dead letter exchange, I can have the exact same queues I already have in my normal exchange, and add all messages there that have been rejected. What's the next step? That really depends on what you want to do with it. You could have some retry mechanism, maybe retry them in an hour, in a day, You could do it manually. You could go in there, see what didn't work, and maybe you realized, oh my God, we had a broken source code deployed, and now this messages can't be handled by the system anymore, so I have to maybe handle them manually, so you don't lose the messages. If it's a system where you know, oh, I don't know, you can also just handle them like a 500, basically, just put them to Sentry. And they will automatically end up in your Sentry or whatever you use for error logging or monitoring, and you don't handle them, so you just delete the queues and didn't work, but you have the information. Routing examples. I concentrate on the topic exchange here. I already mentioned you have pattern matching, and the routing keys are dot separated. So imagine we have like this schema. We have cities, topics, and categories, because we are a service that connects tech communities all over the world. So with a schema of cities, topics, and categories, like this 5 by 5, we have like already 125 different possibilities to build a routing key. For example, it could be a Barcelona Ruby event. Could be one routing key, or a Barcelona Ruby job if you have a job board there, a job page. Or we have not jobs for Ruby, but for testing. And they all start with Barcelona because I live in Barcelona, and I should have rewritten it to Hamburg, I'm sorry. So we could also have a Hamburg Ruby event, that's what we're on today. So different kinds of routing keys. And we would bind the queues to those keys with a pattern matching to it. So for example, Barcelona.hash would capture or would receive a queue which uses this binding key, would receive all messages that have the routing key starting with Barcelona dot. Maybe it only wants to have the events, so you put the asterisk into the center, or you want to have everything about Ruby, you put the asterisk at the end. So you're really, really flexible in the way you're routing. The example I had before was like user registration, so maybe you have like registration.user.new or something like that at a binding key. And you have a system that listens to all registrations, or only user registrations, or only new users, or something like that. So you can always change it, or maybe you have a user edit, user update. So yeah, and that is the part in the center. That's when the exchange decides which queue receives which messages. So one message can go to multiple queues. It doesn't have to go to one queue. Like every queue that has any binding key that matches this routing key will receive the message. A queue can have multiple consumers. If you have multiple consumers, your queue is worked on like much faster. It's just like load balancing. It's on default done in a round-robin way. You can have a consumer that listens to different queues, so to receive more messages, and so on. So you're really flexible in the way how you plug it in together and how you later extend your system. Okay, we talked about publishers, the broker with the exchange, and the queues, and we talked about the consumers. What we didn't really talk about are the messages. The messages in this example, in this diagram, are basically the errors, or on the errors. So the messages are like passed through. We already mentioned the method frame without mentioning it, without naming it. So it has all the routing information and arguments. Like routing information being like the routing key, for example. And we also have a content header frame, which actually has message properties. So for the properties, you see in this, the use by column, it says application. Application basically means it's for you, for the user. It's not used by RabbitMQ. So you're free to put in whatever you want there and handle it however you like. The most important might be the content type and content encoding. So the publisher should set the content type, let's say application JSON, and the content encoding, for example, UTF-8. Then the consumer knows how the message is formatted and how it has to read the message. And usually the consumer should actually deserialize the message. So instead of passing JSON to the application, you might want to have a plain old Ruby object, or at least a hash, or whatever suits you. Also, like the message ID, you can set yourself. If you create it yourself, use UUIDs or whatever. Even the timestamp is up to you to put in there. Also can define an expiration time that the message actually gets deleted or automatically rejected if it's too old. You can set the delivery mode, have a correlation ID, like if you have microservice, you often use a request ID or a trace ID over all your system. You could put it in there, which is really handy for logging over the whole system and monitoring. Advanced properties like priority and so on. Yeah, and what we didn't talk about yet is the payload. The payload is part of the body frame. It's actually what we're sending. That is our message, what we actually want to send. Maybe it's just a user ID. In our case, you can also send whole objects with more information. That depends a bit like how you set up your system, and maybe if you already have plans to later migrate to a different system, then you need more information in there because they don't have all this meta information like RabbitMQ offers you. But the payload is the body, the actual message. I'm good on time, I'm surprised. Maybe I skipped too much. I have some coding examples. They are obviously in Ruby, and I use the bunny gem, which is the most popular. And all other solutions you'll find nowadays online will somehow be based on the bunny gem. That also might explain all those weird images I have in there. So the code examples here, hope you can read them in the last row as well. So I have my RabbitMQ system. It has a URL, and I start my new bunny object, or like a new connection, and I create a channel on the connection. That's the basic, and we'll do it once for the publisher and once for the consumer, for each consumer and for each publisher. When I talk about publisher and consumer, it can be actually the same application. You can actually use it to decouple your current application already. So you publish a message, and you have this big monolith, but you, I don't know, need some background processing in between. So you publish a message, and you then consume it later on in the same application with the consumer. Here I'm declaring an exchange, and and a queue, and I bind them together. So if you look at the last line, where I say queue, which I just created, dot bind to the exchange, which I created above, with this binding key. Example.routing key. So in this case, I don't use pattern matching, but it's a topic exchange here, as you can see in line 3. So theoretically, I could use pattern matching here. And then I publish messages already. So it's just like on the exchange, I just call publish, I put some message in, and I put the routing key in. That is the most important information. Like the message ID and the timestamp are optional. And all the other properties you might want to send. So you have the chance to give a lot of meta information in here. So that was publishing messages. Now we also want to consume the messages. Damn, this thing is kind of broken. As I mentioned before, we have to open a connection, create a channel, the same as before, but now for the consumer. And then we're creating the consumer for the queue. So we already have the queue. Now we need a consumer plugged into it. So we define the consumer. We say on which channel it is, which queue it is, and the consumer tag is an ID. So we can let RabbitMQ generate it. You can also set your own IDs. There are some options to set, for example, if we're sending acknowledgements automatically or not, and so on. And then we're subscribing the consumer to the queue. But before we subscribe him, which is happening in the last line, we're actually creating the logic of what do we do. Like on message delivery, we receive the delivery info, the properties, and the payload. Okay, here obviously it's a simple example. I just put the various information I put into the message out. So I'm left with a timestamp, message ID, a routing key, and exchange. Like there are more properties that you maybe haven't seen me typing, but that exist in there. And finally, you have the payload. If that would be a real consumer, and maybe the payload would be JSON, I might want to create at least a hash now, or better even a Ruby object, call it user or whatever. The application can then handle it. Yeah, and after subscribing, can also say cancel it, because maybe when consumers, I don't know, want to take my consumer offline to work on it for some reason, or I've got a deployment, or it's overloaded, or the external service it is using is like down, and I can actually cancel the consumption of messages and subscribe to it later again, and then all those messages will be waiting in the queue for me. So if all these messages in one system, and that might be a bit spooky because it's like it's your own system. So I mean, it's also the beauty of RabbitMQ. This broker is its own piece of software, meaning you can scale it independently, while in your own code you only have publishers and consumers, which are really small, tiny clients. It's really lightweight software. Most of the logic is in RabbitMQ in its own system. It's kind of a single point of failure as well. So having redundancy, having a cluster setup might make sense. As well, you want to have some monitoring, and which might be the easiest and also really effective monitoring would be to list the queues and check the length of the queues. How many messages are in my queues? In an ideal world, all your queue lengths are always 0, because as soon as something comes in, it already gets consumed. Perfect throughput. You might have some process where you know it take longer. Maybe you have a lot of activity in daytime, and it's like long-running jobs. I don't know, you do image processing, whatever, and you know it. They get handled overnight. So you need different monitoring on different queues. So that's, yeah, just put some threshold in if it's too long. In particular, maybe if you have a dead letter exchange or an alternate exchange, like your error handling processes there shouldn't be any messages in there. Like in an alternate, actually never, unless something's really broken. In a dead letter exchange, yeah, it happens. But put some thresholds in there and see if you have too many errors by just collecting messages in there. Not going into the details of the cluster setup. There's some best practices. There will be a markdown. I'll send around a link to a markdown without all the stupid rabbits, and you can all read all this information which you won't have enough time to read it here. And there are obviously software that makes it easier for you, like the clients. So on a Ruby conference, obviously there is an unconference, sorry. There's a Ruby gem called the Bunny gem, which I mentioned before. But you don't have to use the gem directly, you can also use frameworks. I've never used Sneakers. I implemented something with Hutch, and love to call it Hooch because it sounds nicer. And it's quite nice. It only gives you a topic exchange. It gives you a lot of, has a lot of opinions about how to do things, but it has sensible defaults, and you can still configure basically everything. And if you need something to do directly with Bunny, it uses Bunny itself, so you can still go directly to Bunny. That was like a nice setup. If you use Elixir, then you might not want to have such a need for a message queue, because you're always sending messages in airline systems all the time, but there's also like a hex package for it. If you're talking together, like if you're microservice architecture and other people use Ruby, or other people use Go, or Java, or JavaScript, or Rust, or whatever. Like there are clients for all of that. RabbitMQ is like more than 10 years old. It comes from the banking and finance industry, and it's stable software. It's really well managed and really well documented. So the top link is the reference to the documentation. It's really worth reading it. You can download it for free. You can try it easily. Use Homebrew if you have a Mac. Try it on your own machine. And like this book here is really nice. It's actually inspired me to give this whole talk with all this information, RabbitMQ in depth. And yeah, I just made it on time.
Thank you very much, Andreas, for all the nice bunnies. And you earned yourself a little piece of cake and also some coffee, and all of you as well. And I see you back in this room or in the other one, in the BIM room, in 45 minutes. And next up will be Anna talking.